Okay, in this example, we are given this linear function fx equals 2/3 x plus 1, and we want to find the x-intercept and the y-intercept of this function. In our previous videos, we said the x-intercept and the y-intercept, there are 2 points. So the point the graph intersects with the x-axis is called the x-intercept. So this point is x-intercept. And the point the graph intersects with the y-axis is called the y-intercept. And another property of these 2 points are for the x-intercept, its y-coordinate is always be 0. And for the y-intercept, the property is its x-coordinate is always be 0. So here we can use this property to find the x and y intercepts of this function. So first, we set up this table. If we start finding the x-intercept, okay, because we know for this point, for the x-intercept, its y value is always 0, so we can go ahead to put 0 over here, and then we need to find the corresponding x values. Okay, so this requires us to solve for this equation. To solve this equation for x. So we wonder, when y is 0, what is the corresponding x? And to answer this question, we need to solve for this equation. So we subtract 1 from both sides, and then we multiply by 3/2 on both sides. So x is negative 3/2. Okay, so the x-intercept is the point negative 3/2, 0. Okay, now next we find the y-intercept. Now for the y-intercept, its x value is 0, so we go ahead to put 0 here, and we wonder what is the corresponding y value of this 0. So when x is 0, the corresponding y is 0 plus 1. It's 1. So the y-intercept is 0 and 1. Now let me do another example. So fx equals 1/3 x plus 2, and to find the x and y intercept. So first, to find the x-intercept, okay, because y is 0, so when y equals 0, on the right hand side we have 1/3 x plus 2, and if we solve this equation for x, we have 1/3 of x equals negative 2, so x equals negative 6, right? We multiply by positive 3 on both sides. So this is negative 6. Okay, so the x-intercept is the point negative 6, 0. Okay, so this is x-intercept. And then to find the y-intercept, we let x be 0. Now if x is 0, y is 1/3 times 0 plus 2. So that is 0, 0 plus 2, so it's 2. So the y-intercept is 2, 0. So in practice, when we want to graph this function, we can use these 2 points to graph it. Now sometimes you will find the x-intercept and the y-intercept, they are the same point. So for example, if we're given this linear function fx equals 2x, now you will see the x-intercept and the y-intercept, they are the same point. Let me show you why. So for example, let's find what is the x-intercept is. So to find the x-intercept, we know its y-coordinate is 0, right? Now if y equals 0, when we solve this equation for x, we will have x equals 0 over negative 2, so it's 0. So the x-intercept here is 0, 0. Now to find the y-intercept, we let x be 0. And when x is 0, you see the y is also 0. Now the reason here the x-intercept and the y-intercept, they are the same point, is because if you graph this function fx equals negative 2x, okay, now let's see if I want to graph this function. Let me use some other points. So when x equals 1, y is negative 2. When x is negative 1, y is positive 2. So we have this point 0, 0, and 1, negative 2. So from this table we have a point 0, 0, which is here, and 1, negative 2, which is here, and negative 1, positive 2, which is here. So if I connect these 3 points, now you can see the graph of this function. It is across this point 0, 0, which we call the origin. So the graph it across the origin, and it doesn't intersect the x-axis or the y-axis. No, it doesn't. So that's why here the x-intercept and the y-intercept, they are the same point, 0, 0. Now if we have a function like this, in order to graph the function, we need to find an actual point. For example, here I found this actual points, so I can graph this function.